U4-Architecture, let us see the features of 8086 microprocessor. The first and foremost feature is 8086 is a 16-bit microprocessor that indicates it has 16-bit ALU and it performs operations on 8-bit or 16-bit data. And it has a 16-bit data bus and 20-bit address bus. So at a time, the 8086 microprocessor can receive or send 16-bit data at a time and 20-bit data bus. So the data bus indicates external memory capacity of a microprocessor. So 8086 microprocessor has 20 address lanes. So total memory locations are 2 power 20, that is equal to 1 megabyte of memory. And next, it uses memory segmentation concept. So in memory segmentation concept, the total memory 1 MB memory is divided into fixed size of segments. With the help of memory segmentation, the microprocessor can access the memory easily and fastly. And it has a multiplexed address and data pins AD0 to AD15. With this, the number of pins per IC will be reduced. And it uses two-stage pipelining. The two stages are fetch and execute. So the 8086 microprocessor architecture, at a time it can perform two operations, that is fetching instructions and executing instructions. It performs parallelly both operations. With this, the speed of operation will be increased. The efficiency of the processor system will be increased. It has 6 bytes of instruction queue. So with the help of this instruction queue, the 8086 microprocessor fetch 6 instruction bytes before execution. And the 8086 microprocessor is designed to operate in two modes, that is minimum mode, it is also called single processor mode, and maximum mode. Maximum mode means multi-processor mode. And the 8086 microprocessor is available in 3 clock rates, which is on 5 MHz, 8 MHz and 10 MHz range. And it is packed in 40 pin DIP package, dual in pin line package, and it requires plus 5 volts power supply. And it is fabricated using HMOS technology, that is high density MOS technology, and it contains approximately 29,000 transistors. This is about the features of 8086 microprocessor. Coming to architecture of 8086 microprocessor, it is divided into two parts or two individual functional units. Number one is bus interface unit and execution unit. Here, these two parts works independently. So these two parts are operated in parallel for implementing pipelining. So here see BAU and EU forms the pipeline. So this is the architecture of 8086 microprocessor. It is divided into two parts, that is bus interface unit, that is the upper one, lower one is execution unit. So the upper one consists of different parts, queue and some other is physical address adders, code segment registers, right? And coming to EU, it contains registers, ALU, and control circuitry, decoding circuitry also. Let us see in detail. The first part is bus interface unit. So the bus interface unit handles all transfer of address, data and code on buses. So name itself indicates bus interface unit. So the bus interface unit is the responsible to interface the microprocessor with external world. So it will communicate. It helps the BIO helps microprocessor to communicate with external world. External world is nothing but memory and IO devices. And the BIO sends 20-bit physical address. Yes, it has an physical 20-bit physical address generation circuitry. By using 16-bit address, it generates 20-bit physical address of data or instructions stored in memory or and in IO port. Next, coming to the BAU responsibilities for BAU is one of the responsibilities read and write operations of memory and IO. It will take care of read and write operations. That is, we call it as bus operations of the microprocessor. The BAU consists of instruction queue, segment registers, instruction pointer, and 20-bit physical address calculation circuit. So coming to instruction queue. So here, while EU is executing an instruction, the BAU will fetch up to 6 instruction code bytes from memory and stores them in a first in first out group of registers set, which we call it as instruction queue. So this queue will work first in first out fashion. So the 8086 microprocessor will fetch 6 instruction bytes before execution of the program. And when EU is ready for its next instruction, it simply takes instruction bytes from instruction queue. The EU will receive the instructions from this instruction queue. So here we can see non-pipelined architecture of 8085 and pipelined architecture of 8086. So in the new future in 8086 helps to perform parallel processing, right? So here the pipelining concept is implemented in 8086 using an instruction queue. So this is queue is in bus interface unit. The execution unit is responsible for decoding and executing instructions. So in this figure we can see while executing first instruction, the BAU fetches next instruction, that is parallel processing. So this structure we call it as pipeline architecture. But there is one problem. While executing branch instructions, after execution of branch instructions, the program control will be transferred from current instruction to another instruction, not in a sequence. Maybe that is depends on condition. Some branch instructions works based on condition. If the condition is false, it will go to the next instruction. If condition is true, then what happens? The program control will be transferred from current location to another location. At the time, the instructions, the fetched instructions stored in queue will be cleared, and the bus interface unit starts fetching the instructions from new address location. So at the time, the processor takes more time. So nowadays the microprocessors are designed using some logic, that is branch prediction logic circuit. Nowadays microprocessors are coming with branch prediction logic circuit that helps with that circuit the time will be reduced. Not for all cases. If the uh, if the if after execution of branch instruction we'll get some address, if that address is same, then the time will be reduced. Coming to segment registers of which is available in 80 bus interface unit of 8086. So there are 4 segment registers because the 8086 microprocessor will work with 4 segments at a time, at any instant of time. The segments names are extra segment, code segment, stack segment, and data segment. So these segment registers are 16-bit in size. The these registers holds starting or base address of a particular segment. For example, these are the segment registers holds. And coming to the instruction pointer, it is a 16-bit register and it holds the address of next instruction to be fetched from memory. It is nothing but a program counter. It is also a 16-bit register. Next, so coming to segment registers. So in 8086, it uses memory segmentation divided into, there is 1 MB is divided into logical segments of each segment size is 64. Here the segment registers are used to define the starting address of logical segments. Let us see in this diagram. We can observe the SS is consists of 9000H starting address of stack segment, ES 7000H starting address of extra segment, DS 4000 starting address of data segment, CS 2000 starting address of code segment like this. And coming to instruction pointer. So the instruction pointer holds the offset address of the next instruction to be fetched from code segment. So the IP instruction pointer stores offset address of code segment. And coming to the offset address, what is the offset address? Actually, the segment size is 64 kilobytes. In that 64 kilobytes, the offset address will define a particular address location from the starting address like this. So next, 20-bit physical address calculation. So 8086 microprocessor will generate 20-bit physical address with the help of 16-bit segment address and offset address. The segment register defines the starting address of a segment, and the offset address. The offset address will define the a particular address in the segment. Here, for example, CS code segment is having 20,000 H and IP instruction pointer having 5678 H. Then the segment address, that is base address, is equal to CS into 10H. So here the bus interface unit, what it does here, it will shift the contents of code segment registers to the left side 4 bits, or we can say the bus interface unit will add 4 zeros at the lower side of the starting address of the segment. That is, CS is having 2000, and after adding 0 to this number, it will become 20,000. Now, offset address is adding to this address. So we'll get 25678. So this diagram will show clearly about generation of 20-bit physical address. Right? Coming to the execution unit. So the execution unit responsibilities are decoding the instructions and executing the instructions. The heart of execution unit is the arithmetic and logical unit. So here the 808 the execution unit performs the following steps. What are the 5 steps? It reads the first in first out instruction at a time, instruction say queue, that is, it will receive the instructions from the queue, that is first important, and it decodes the instructions. After decoding, the 8086 knows what is the operation and where are the operand and where it has to store the results. And after decoding that, the execution unit will read the data from general purpose registers, and if the data is in memory, it generates the addresses if necessary, that is based on the data available. If the data is available in memory, then it must generate the address. So that address details, it will pass them to the BAU and requires BAU to perform read or write cycle to memory or IO, and performs the operation. So performs the operation is nothing but execution. And during execution, you may test the flag. It has a flag register of 16-bit size. It will test the flags and updates them based on the result of the execution or operation. And the if the queue, that is instruction queue, is empty, the execution unit will wait for next instruction byte to be fetched and shifted to the top of the queue. So when the AU will wait, if program has, or if program has a branch instruction, then the address next instruction will be changed, not the current instruction, current address. It will be after execution of branch instruction, the control will be transferred to another address, new address. So at that time, the queue, instruction queue will be cleared. All the instructions in the queue will be cleared. So at that time, the you will wait for next instruction. And coming to execution unit, it consists of 16-bit ALU registers, general purpose registers, and index and point registers, and the flag register, and it has a control circuit and decoding unit also. Coming to 16-bit ALU, it is the heart of execution unit. The 16-bit ALU is the heart of execution unit. Here, the 16-bit ALU will perform operations on 8-bit data or 16-bit data. That is, it performs 8-bit based operations and 16-bit based operations. What are the operations it is going to perform? Arithmetic operations such as addition, subtraction, multiplication, division, increment, decrement, and comparison, etc. And the logical operations such as AND or NOT, XOR, shift, and rotate operations. This is the shape of ALU. And coming to next part, the control circuitry. So after decoding the instructions, the execution unit will know what are the operations it is going to perform and what are the registers involved in that operations, or what are the memory involved in that operation. According to that, it will direct or it will generate the control signals to perform the operation. And instruction decoder. So the decoder will translate the instructions fetched from memory, that is from queue, into series of actions. And coming to registers, other part is the registers are used to hold data or address and status of the results temporarily. So EU has 9 16-bit registers. Some of registers are general purpose registers. So this is the architecture of 8086 microprocessor. We started with features of 8086 microprocessor and architecture. So main important is the architecture of 8086 microprocessor is divided into two parts: bus interface unit and execution unit. Independently both units works independently. So the system throughput will be increased, the speed of operation will be increased. So this is about all about 8086 microprocessor.